Our next lesson is called Interpreting Residuals from a Line. We'll start with example 1, calculating prediction errors. The gestation time for an animal is the typical duration between conception and birth. The longevity of an animal is the typical lifespan for that animal. The gestation times in days and longevities in years for 13 types of animals are shown below in the table. So you'll see the list of the type of animal, the number of days of gestation time, as well as the number of years for longevity. Underneath, they've created a scatter plot for this data. We're going to start out today's lesson by finding out how to find what's called the least squares line or line of best fit. Okay, so I'm going to jump ahead a little bit and kind of go through the first exercise with you, and then I'm going to show you some important keystrokes on your graphing calculator. So for exercises 1 through 4, we'll be using that information. It says finding the equation of the least squares line relating longevity to gestation time for these types of animals provides the equation to predict longevity. So by calculating the equation for this line, you can use the equation to actually make predictions. It also says, how good is the line? In other words, if you were given the gestation time for another type of animal not included in the original list, how accurate would the least squares line be at predicting the longevity of that type of animal? So in exercise 1, it says, using a graphing calculator, verify, which means check, that the equation of the least squares line is y equals 6.642 plus 0.03974x, where x represents the gestation time in days and y represents longevity in years. So this is where we're going to take a look at our graphing calculator. So I'd like you to go back up to where we were by the table, and we're going to take some notes up there. So first of all, we're using gestation time and longevity. So when we go to enter these lists of data into our calculator, gestation time is going to be listed as L1, and longevity will be listed under L2. So I want to talk to you about how to get these lists into the calculator. So please grab your graphing calculator at this time. Okay, now that you're at your graphing calculator, I want to show you the keystrokes, and at the same time, we'll write some information on our notes to remind us of how to get to all of these things. Okay, so first of all, we have lists for gestation time and longevity. In order to enter the list of data, you are going to hit Stat. So the Stat button is 2 buttons to the right of the alpha button. You're going to hit Stat, and then you're going to choose choice number 1, which is Edit. When you do that, you will see L1, L2, L3, and so on listed there. In order to enter this data into the table, all you have to do is type the first number and hit enter. So when I look at baboon as 187 under L1, 187 is going to get entered there. Then hit enter. Black bear is underneath it at 219. So I enter that and hit enter to go to the next line. Then beaver's at 105. Okay? At this time, pause the video and please enter the rest of gestation time L1. Resume the video when you're done to make sure that you've done it correctly. Okay, now you should have had time to enter the gestation time under L1. It should look similar to mine, all numbers listed vertically under L1. Now it's time to go and enter the data values for L2, longevity in years. So you'll use from your arrow keypad the right arrow to go over to L2. And now you will do the same thing that you did for gestation time. In this column, you will enter all of the numbers for longevity in years. So the first one for baboon is 20. Then we hit enter to go to the next line and so on. Please pause the video, enter everything for longevity, then resume the video when you're ready to check your answers. Okay, at this time, you've had time to enter longevity L2. So you can see what your L1 and your L2 should look like. They should look exactly like the table from your notes. Now let's go back to our notes and write down the keystrokes that we used in order to be able to enter these lists. So for step 1, we have to enter 2 lists in the calculator. So we'll just do calc for calculator. The way that we did that was the following keys. I'll write them in order. We hit stat, we chose edit, and then we enter numbers and hit enter. Okay, so that's how we got the two lists into the calculator. Now, in order to check or verify that the equation of the least squares line, or the line of regression, or the line of best fit, you're going to see those words used interchangeably, we're now going to go to the calculation part on our calculator. So this is where we left off on the calculator with our lists entered. In order to find the linear regression, least squares line, or line of best fit, we need to go back to stat, but instead of staying underneath the edit section, I'm going to hit my arrow keypad to the right and go to calculate, and we are going to choose linear regression. Now, my calculator on the iPad is a little bit different. It only has certain things that we use. You should have a lot of options there. However, I believe that they've changed it on purpose on this to make sure it matches with the number that you would have. We're going to choose number 4, linear regression. You're going to see AX plus B. They use A instead of M for MX plus B. That's the form that we want to choose. Now, if you chose 8, it's just going to put the y-intercept first, and the b would be the slope in front of x. But since we're used to mx plus b, we're going to choose number 4, or just look for linear regression ax plus b. We're going to pick that one. So you can either use your up and down arrows and hit enter, or you can actually type the number 4. Now, when you hit this, you're going to get a screen that looks like this, and it's going to ask you what is your x list and what is your y list. Now, if you remember, we used L1 and L2, the first two. So it's already defaulted to those choices. We put gestation time under L1 and we put longevity under L2. If for some reason you used 3 and 4 or any other lists, if you look at your keypad, above the number keys in blue are the words L1, L2, L3, and so on. So all you would have to do is hit second and then whatever list you use to type that in instead. But we're all set. Frequency can stay as it is. There's nothing else you need to change, okay? So all you have to do is hit enter, and you can see it will calculate all of your information for you. So it's reminding you that it's in y equals ax plus b. Think of a as mx plus b, like the slope. It tells you your a value, and it tells you your b value. Now, you might potentially have an r squared and an r value underneath. Some of you might not. Do not worry about those values right now at this time. Later on, when those are applicable, I'll make sure that everybody knows how to make sure they can see them. Right now, we're only concerned with y equals ax plus b with the a value and the b value. So that's telling me that the slope looks like it's supposed to be 0.03974, and then my y-intercept or b value should be 6.64165, etc. Okay, so at this time, let's go back to our notes. And if I scroll down at the equation they said I should have right here, I have officially verified that that is correct. That's the same equation I got when we calculated the linear regression on our calculator. Now let's go back up underneath here and put the directions that we used in order to do that. So we're going to write number 2, find the linear regression, also known as the least squares line or the line of best fit. So in order to do this, we are going to go to stat, but remember, we're not going to stay at that edit screen. We're going to arrow over to calculate, and then we are going to pick number 4, which looks like linear regression. That's how it's abbreviated like that. And it'll have the ax plus b in parentheses next to it. Now remember, once you hit enter, or you hit number 4, okay, you are going to have to verify the lines. Now we already had L1 and L2 in there, and I described to you how to get lines other than that. Okay, so now let's go down to actual question number 1. Using the graphing calc verify, we did that. We can say, all set here. We got the same answer when we did it on our graphing calculator. Now moving on. The least squares line has been added to the scatter plot below. So you had your original scatter plot, but then they took and drew the actual line of regression or line of best fit or least squares line onto the scatter plot so you can see where it falls. So the least squares line is not necessarily going to hit any points. It won't hit all of the points. You're not connecting them from dot to dot to dot. It is a general trend line that is drawn in towards the center or middle of the data. Okay, so now number 2 says, suppose a particular type of animal has a gestation time of 200 days. Approximately what value does the line predict for the longevity of that type of animal? So what we'll need to do is we'll go and find 200 days on gestation time, which is the x-axis, that's here. And we will do the best we can to follow it vertically up. If you have a ruler, that would be very helpful. Once we hit the line, we're going to follow that over this direction to see about where we think that would land. To me, that looks at like about approximately 14 years. Okay, so we use 200 days for an x value, and we're going to say approximately 14 years. Now, give or take. If you were a little bit off from that, I would still take your answer. Number 3, would the value predicted in question 2 necessarily be the exact value for the longevity of that type of animal? Could the actual longevity of that type of animal be longer than predicted? Could it be shorter? So this question gets at the point that, remember, our least squares line is going to give us a prediction, not an exact value. It is a general trend line that we can use to make predictions. So for this question, we are going to make sure that we write it is not the exact value. It could be longer or shorter. And then let's put it's a prediction. So the least squares line is only going to give you the prediction. If you want the exact value, you have to go back up and look at the actual data that was collected and placed in the table. Now it says you can investigate further by looking at the types of animals included in the original data set. Take the lion, for example. Its gestation time is 100 days. You also know that its longevity is 15 years. But what does the least squares line predict? Notice that word again, for the lion's longevity. If we wanted to know the prediction, we would take the x equals 100 number for gestation time, and we would actually plug it in x's spot to find out that the prediction would be 10.6 years. Now, in actuality, we know from the table it's supposed to be 15 years. So you can see that it just gives you a prediction. So number 4 says, how close is this to being correct? More precisely, how much do you have to add to 10.6 to get the lion's true longevity of 15? So the actual longevity was 15. My predicted value using the actual equation of the least squares line was 10.6. If we subtract those two values, we get 4.4. So it is off by 4.4 years. Now, the way that we show this, you can show this on the graph. It says you can show the prediction error of 4.4 years on the graph like this. So what you'll see has been done is that we found the actual real-life data point for the lion, which is right here. 100 days and 15 years. Where it lands on the line is right there. So we mark it with a vertical line. So we're going to put vertical line. And that vertical line is either going to be above the least squares line or below, depending on what you're off by. So the actual was 4.4 years higher, so we're drawing our line up to the actual data point. If our prediction was higher than the actual, we would draw the line down. So number 5 says, let's continue to talk about the gestation times and longevities of animals. Let's specifically investigate how accurately the least squares line predicted the longevity of the black bear. So what is the gestation time for the black bear? We would go all the way back to our actual table of data, and black bear is right here. Gestation time is 219, longevity is 18, it claims. Okay, so when we go back to exercise 5, what is the gestation time for the black bear? 219 days. Now we're going to look at the graph. Roughly, what does the least squares line predict for the longevity of the black bear? So we're going to find where we think is about 219 days. We'll go back up here. So we're looking at just a little bit over 200. Probably talking about here maybe. And then when we follow it over, it looks like it's about 15. So we'll say, for that question, about 15 years. Now C says, use the gestation time from A and the least squares line, and it gives you the equation, to predict the black bear's longevity. They'd like us to round our answer to the nearest tenth. So remember, for this one, you're going to take the equation, but in X's spot, they want to know what it is for those 219 days, so I'm going to put 219 for X. When I evaluate that on my calculator, I actually get 15.3 years. And we had already said by looking at the table of values earlier that the actual longevity should be 18 years. So how much do you have to add to the predicted value to get the actual longevity? So this is where we determine how far off are we. The actual data point is 18. Our predicted value was 15.3. And it's just the same way we did it before, actual minus predicted. When we actually subtract these, we get 2.7 years. So we were 2.7 years off with our prediction. For part F, it says show your answer to part E on the graph as a vertical line segment. So we're going to go back to the same graph that we used before to show our error for the lion, and we're going to show it now for the black bear. So the actual point is right here. This is for the bear. And we were below, so we're going to draw our line up to the actual data point, and we were off by 2.7 years. So we can draw in that vertical line. Now let's move on to example 2. Example 2 is residuals as prediction error. So in each example above, you found out how much needs to be added to the predicted value in order to find the true value of the animal's longevity. In order to find this, you have been calculating the actual value minus the predicted value. This quantity is referred to as a residual. So that's a vocabulary word. Okay, the residual is the actual y value minus the predicted y value. So that's the formula you're going to want to use to calculate residual. So we were actually calculating residuals in the last couple examples. We just didn't give it its formal name. That's what you were finding. So you can now work out the residuals for all of the points in our animal longevity example. The values of the residuals are shown in the table below. So rather than having you calculate them, I've calculated them for you. You should see a couple of them familiar here. Here's the black bear that we already did. We talked about the lion already. Okay, so you can see those numbers are the same numbers we had before, but now the residuals have been calculated for all of the rest of the animals as well. These residuals show that the actual longevity of an animal should be within 6 years of the longevity predicted by the least squares line. I can tell that by looking at the residuals because the highest one I have is 5.9, and the lowest one I have looks to be a negative 5.8. So we're either within 6 above or 6 below the actual value. Suppose you selected a type of animal that is not included in the original data set, and the gestation time for this type of animal is 270 days. You would substitute x equals 270 into the equation of the least squares line. So you can see right here, it's been substituted in for x, and you would get a predicted value. So let's make sure we remember that this is the predicted value, because we use the equation of the line, of 17.4 years. Now let's answer the exercises that follow. Think about what the actual longevity of this type of animal might be. Could it be 30 years? How about 5 years? Okay, so first of all, we know that the predicted value is just a prediction and that our values could be above or below. So we'll say it could be above or below 17.4 years. Okay, in number 7, it says, judging by the size of the residuals in our table, what kind of values do you think would be reasonable for this longevity? So this is getting more specific. Looking at it in general, could it be above or below? Of course. But we just said it seems that we're within 6, either above or below. So if I went a little bit above or I went a little bit below by that amount, that would be a better range. So if I went 6 below 17.4, I'd be at about 11 or 12. So I would say about 12 to, let's say we went 6 above 17, that'd be about 23. So about 12 to 23 years, because some residuals are below by up to 6 or above by up to 6. Okay, so you would want to look at an animal with that similar type of longevity. Now it says, continue to think about the gestation times and longevities of animals. The gestation time for the type of animal called the oscillate is known to be 85 days. So the least squares line predicts the longevity of the oscillate to be. So again, the prediction here, because we're using the equation, we plug in x equals 85, and we get a prediction of 10.0 years, or 10 years. Okay, so number 8 says, based on the residuals in example 3, would you be surprised to find that the longevity of the oscillate was 2 years? Why or why not? What might be a sensible range of these values? So let's think about this. Remember, if we want to find the residual, we're going to take the actual, which for us now we know is 2, and we're going to subtract the predicted, which is 10. That's giving us a negative 8. So if we go back and actually look at example 3 and we look at the types of residuals we have, remember, we don't have any residual that's less than negative 5.8. So this just gave us negative 8. So I would be surprised because it's not in line with the rest of the residuals that we have for our data. So here, I would say I would be surprised because the smallest residual is negative 5.8. The oscillate, according to our calculations, right, would have a residual of negative 8. So it says, what might be a more sensible range? I would assume it would be, now we want to make sure we're within the normal residual range, so I would say it would be between 6 and 14 years. That would be a better prediction. So now for number 9, it says we know that the actual longevity of the oscillate is 9 years. So in question 8, we were assuming it was a 2 and using 2 as a possible actual value, but now in number 9, it's telling us the actual data. We know the actual longevity of the oscillate is 9 years. So they want us to find what is the residual for the oscillate. So in order to find the residual, we'll write the residual is, remember that we're going to take the actual value, which is 9, and subtract the predicted value, which you see just up above by using the equation was 10 years. So minus 10, we have a residual of negative 1. Now that residual makes much more sense because it falls within the range of the normal residuals that we have for this data. And that concludes your lesson on interpreting residuals from a line.